Hello everyone, welcome to the Mathematics Fantastic series. So the main aim of this series is to clear the basic concepts of various mathematical theories, because these theories are used in various fields, science, in many other science fields like physics, chemistry, botany, zoology, then microbiology, as well as many other fields of commerce, accounts, and of course computer science, IT, artificial intelligence, machine learning. So these things, they are used in varieties of applications. So the main aim of this particular series is to clear the basic concepts. Okay, so we start with the graph. Okay, so why graph? Okay, so why do we use graph? So graphs are the common methods to show the relationship between various data sets. So we may have some data sets and we can find some relationship between those data sets. They can be related in various ways. So graph, they make it easy to interpret the enormous amount of data available in various formats. So in many cases we have data, enormous amount of data we are having. So graph, it makes us easier to just visualize it in a proper way, okay, so that it becomes easier for us to make the analysis. So unknown value can be easily interpreted from the graph, as we'll see. Then graphs can be used to make analysis, and graphs are used in almost every fields. So what this is how to draw a graph. So we have when we want to draw a two-dimensional graph, so this is a 2D graph using x and y axis. So this is the x-axis, this is the y-axis. Any variable can be on the axis, and the one which depends on them in that particular is the y. Okay, so we have this xy plane. Okay, we will plot. So we have example. So we have v versus I. So we can be maybe like we can have v as a voltage, I as a current, or any other variable. So this readings we have taken through some experiments. So for v equal to 1, we have I equal to 10. For v equal to 2, we have I equal to 20. V equal to 3, we have I equal to 30, and so on. So before drawing the graph, we choose the scale. Okay, so here in this case we just put v on the y-axis, I on the x-axis, and choose the proper scale so that this readings, they fit on this scale. So as we know, for I we have from 10 to 40, so we are using this particular scale. So this one marking is of 10, so we have 20, 30, 40, and so on. And I, it goes from 1 to 4, so we selected some more points. So this is one scale, 1 unit, 2 unit, 3, 4, and so on. Now we will plot these points. So the first one is when v equal to 1, I equals 10. So how to plot this point? So here, this is v is 1 and I is 10. So this is where they meet. Okay, this is where they meet. So this 0 shows the first point. Then second, 2, 20. So this is 2 and this is 20. Okay. Then 3, 30. So this is 3 and this is 30. So this is how we just put the points. Okay, and then finally how we do this, we just draw a straight line passing through all the points. Okay, so this particular graph is a linearly increasing graph. As we see, as x increases, y also increases linearly, and this graph is passing through the origin. Okay, then we can just find some unknown values. What are the unknown values? As we can see, when we draw this graph, as we can see, we have only taken 4 readings, but we can know some unknown values also. Like suppose we want to know for v equal to 5, what is the reading for v equal to 5? So we just take this 5 is here. Oh sorry, this is 3.5, not 5. So 3.5. So 3 and 4, between 3 and 4 we have 3.5. So this 3.5, it is touching this line at this point. Okay, so correspondingly we draw perpendicular to x-axis, and this is what we get. So for y equal to 3.5, sorry, this 3.5, the x reading is 35. Similarly, if we want to know for 1.5, we can just draw a line from 1.5 of v and touch it down here. So this becomes that particular value. So it is roughly 15. So this is how we can get the unknown values. Okay. Now generally when we draw the graph, we are interested in the slope. We are interested in the slope of the line. Okay, so how do we find the slope of the line? Let us see now. Now in order to find the slope of this particular graph, of this particular line, what we do is we take randomly any 2 points on this line. We take randomly any 2 points on this particular line. As we see, we have taken here 2 points. One point is here and other point is here at this point. So the formula for finding the slope is y2 minus y1 upon x2 minus x1. So we can take this any of the value as x1 y1. So let us take this is x1 y1 and this is x2 y2. So y2 minus y1 upon x2 minus x1. So we can find the slope of this particular line. Okay, so this is how you find the slope. Okay, so the slope is 0.1. okay, so the slope is 0.1. so when you find the slope, we get this value as 0.1. okay, now we have this equation of a straight line. So we have a mathematical relation which gives the equation of this straight line. So this equation is given the y equal to mx plus c. Okay, so y is the any point on the y-axis, x on x-axis, m is the slope, and c is the intercept on the y-axis. So this intercept of y-axis, as we can see, the graph is passing through the origin. Okay, as the graph is passing through the origin, c is 0. Okay, so this equation, how we write this equation in this form is y equal to m into x. Now m is 0.1, so y becomes 0.1 times x. Okay, so this is the equation for our particular case. We get this equation. Now we can also find the unknown values using this equation of the straight line. Okay, so if we know y is equal to, how to find x, so we just use this equation y equal to mx plus c and put the values. So we get x equal to 20. So if we know the value of x, how do we calculate y? We use the same equation, y equal to mx plus c, and put the values, and we get this y equal to 2.5. So this is the significance of this particular equation, that we can find any other point if we know the other things. Now this the previous graph was a linearly increasing graph. This particular graph is a linearly decreasing graph. So we have r versus I graph. So as we decrease r, I increases. So they are not linearly increasing. It means that any coordinate on x, when any value of x is increasing, it decreases the corresponding value of y. Okay, so when one is increasing, other is decreasing. So this is a linearly decreasing graph. When we find the slope of this particular graph, we get it negative. As we can see, we just took two random points x1 y1 x2 y2 and found the slope using m equal to y2 minus y1 upon x2 minus x1. So we got we get this value m equal to minus 0.095. So this negative sign shows that the graph is linearly. So actually this is a linear graph. So it is like when one coordinate is increasing, other is decreasing. So this is the equation of a straight line for this particular case, y equal to mx plus c, m is negative 0.095. okay, but now in this case the intercept on the y-axis is not 0, because as we can see, this graph is not passing through the origin. It is having some intercept. This intercept is 5 plus 5. So this is c equal to 5. Okay, so we plug in this values in this particular equation. So what we get, y equal to m is minus 0.095 into x plus c. C is the intercept, so this is the equation we get. Okay, now if we know the value of y, we can find the value of x. So if y is 2, we get x equal to 21.05, putting the values here. If we know x, we can find the corresponding value of y, plugging in the values in this particular equation, and we get y equal to 2.625. So this is what we get. Now here as we can see what the significance of slope is. So here we can see there are 4 lines. This one, this is the red line, then the blue line, the green one, and the yellow. So in this particular case, this number 1 line, which is red one, the slope of this line is 0. Okay, the slope, it is not having any slope. Okay, it is just a horizontal line. If you find the slope of this line, it is 0, because x changing, sorry, y is not changing actually. Okay, you can see y is constant throughout this line. X is changing, but y is not at all changing. So if we plug in the values, slope is y2 minus y1 upon x2 minus x1. So this, since y is not changing, this is 0. So because its slope becomes 0. Then if we compare the slope of line 2 with this line 3, the slope of line 2 is less as compared to the slope of line 3. Okay, so this line is having more slope. If you plug in the values, if there are no actual values there, but if it had some values on x and y, and if we find the value of slope of this 3 and with 2, so the slope of 3 would be more as compared to slope of 2. Okay, then regarding the slope of this particular line, which is parallel to the y-axis. Okay, so if we find the slope, here we see x is not changing. Okay, so when x is not changing, what slope we will get? Okay, so the formula for slope is y2 minus y1 upon x2 minus x1. So in this case, because x is not changing, so this becomes 0, x2 minus x 0, and whatever value we are getting, so any number divided by 0 is infinity. So the slope of this line, yellow one, is infinity. Okay, so these are the various things we get. Now apart from the linear graph, we also have exponential graph. Okay, so this graph, as we can see, it is not the linear graph. It is this graph will satisfy this particular equation, y equal to e raised to minus kx. Okay, so negative sign shows that it is exponentially decreasing. Okay, why it is called as exponential? It is suddenly, as we change a small change in the value of x makes a very big change in the value of y. Okay, it is not a linear graph, it is an exponentially decreasing graph. So see the variation as some values are given here. So when y was equal to 5, so this is y equal to 5, we are at this point, y equal to 5, x was equal to 5. Okay, roughly. When we change the value of x to 1, y is 29. So you can see the change in y was only 4 units, but here there was a large change to 24. Okay, a change by magnitude 20, no, not magnitude, but it decreases by 24. This decreases by 4, this decreases by 24. So this is how we get the variation for exponential variation, sudden change. Okay, so how to find the slope of this particular curve? We cannot take just two values from anywhere here. We have to take the tangent to this curve. Okay, so if you plot a tangent is a line which is touching this curve, blue curve at one point. Okay, so we can just take the tangent and take any 2 points on this tangent and do the same procedure, y2 minus y1 upon x2 minus x1. Okay, this is an exponential graph, which is actually exponentially increasing graph. Okay, so this for y equal to some value 0.5, we have it is 10, and as we increase the value of y to 5, it becomes almost 60. So this is an exponentially increasing graph. Okay, this satisfies this relation, y equal to e raised to kx. K is some constant here. So you can see the variation here. When y was equal to 0.5, x was equal to 20. When y became 2.7, x became 70. So this is the variation we are getting. So we can even find the slope of this curve using drawing a tangent to this curve. So y, same formula. Okay, this is how we find the slope of this graph. So that's all for this particular session. This was just a startup. You can study by yourself some more things regarding the graph. Thanks for watching.